If we were to take a square and fold it along its diagonal, it would form a special right triangle, in this case a 45, 45, 90 right triangle. And as you can see, this leg and this leg on the right triangle are the same. This angle is the 90-degree angle, and then these two angles are the same. And because they're both the same and have to add up to 90, each of them is 45 degrees. So one there and one up here. And this triangle is also called an isosceles right triangle. And isosceles simply means two sides are the same. And the prefix iso means the same. Alright, what I want to focus on now are the sides and how they relate to one another. First of all, because these two sides are the same, these two legs, I'm going to assign them both a value of 1 for now. And what I want to figure out is the length of the hypotenuse, c. So we'll do that with the Pythagorean theorem. 1 squared plus 1 squared equals c squared. And if we clean this up and solve for c, we learn that c is the square root of 2. And the square root of 2 is a little less than 1.5. It's about 1.4. So that's the length of the hypotenuse. So I'll go ahead and replace this c with the square root of 2. Now what's nice about this triangle is that that relationship of 1, 1, and the square root of 2 is preserved even if you change the lengths of the legs. So, for example, if I change this leg and that leg, and I make their values instead, let's say 5, then the hypotenuse will no longer be just the square root of 2, it will be 5 the square root of 2. And in similar fashion, if I were to change the length of the legs again, say to 7 and 7, the hypotenuse would then become, as you probably can guess, 7 the square root of 2. Alright, let's take a look at a few examples. In this first example, each leg is 7, so therefore the hypotenuse will be 7 times the square root of 2. In this next example, each of the legs is the square root of 3, so to get the hypotenuse we'll just multiply by the square root of 2 and get the square root of 6. In this third example, something different's happening. We're given the hypotenuse and we're going back to a leg. So because we're working backward, instead of multiplying by the square root of 2, we will divide by the square root of 2. And when we divide by the square root of 2, we learn that x is 5. And in our final example, again we're given the hypotenuse and we're going back to a leg. So like before, we will divide by the square root of 2. So we get 20 over the square root of 2, which is a perfectly fine answer, but some of you probably are in the habit of rationalizing your denominators, and to do that we would multiply top and bottom by the square root of 2, and our numerator now is 20 times the square root of 2, and our denominator is now 2. And of course that cleans up to 10 the square root of 2. Let's look at an application. Catchers have to throw from home to second often to catch runners stealing. Let's figure out how far that distance is. First of all, notice that the base paths form an isosceles right triangle with that length that we're looking for. And each of these lengths is 90 feet. So I'm going to put 90 feet here and 90 feet over here. So now we can get the hypotenuse. We have a 45, 45, 90 right triangle. So therefore, that distance is 90 times the square root of 2 feet. In an application, it's often nicer to see what the decimal equivalent is. And if you put that expression into your calculator, you get about 127 feet. And that's it.